we're going to look at Pig and Hive, and I'll explain what those are. Before I do that, I'll just describe this one last slide on Amazon S3. Amazon S3 is the simple storage service at Amazon and provides low-cost, easily accessible storage. A great advantage of this, if you're running on Amazon EMR, is Amazon EMR has direct access to the S3 storage. So it's very rapidly loaded in to that environment. You don't have long upload transfer times, things like that. And you can also store your output in an S3 location, which are called buckets. You can make those buckets public so that other people can gain access to the data sources, and so it's a useful thing to use. And after we do the first Pig example, I'll go into S3 for a second and show you how to create a bucket. Alright, so Pig is one of the first intermediate languages that has been developed to deal with analysis in the Hadoop environment. As we saw earlier, a MapReduce program written in a native programming language requires that programming expertise and knowledge of the data structures, and it can be time consuming. So you've got to write something customized in Java or Python or whatever. Pig is designed to remove some of that barrier, and this is another, sort of cutesy, at the whim of the developer name for a project, but it is called the Pig project. The programming language is actually called Pig Latin, and not the same Pig Latin that you learned in grade school. And we'll see kind of a theme running through some of these things of cutesy names. Pig was originally developed at Yahoo, and in comparison to Hive, it is a little bit more open-ended in its structure and syntax. So it's like a simplified programming language in a way that hides a lot of the complexity of what it's doing behind this simple code. So you can write a simple statement that's going to go out and execute across all the machines in your cluster. We are going to use the Hue environment that we saw at the end of part 3 to run our Pig examples. So there's a Pig editor in Hue, and if you're interested, there's also a command line interface called Grunt, naturally, but we're going to use the editor in Hue. I have on the slide the default login and password for Hue, but it looks like, at least in my current session, that you can type in whatever you like for that first launch of Hue. So what we're going to do is analyze the complete works of Shakespeare. We're going to just do a word count of Shakespeare's works. The original file that I'm working from is linked here in the slides if you want to get a hold of that. But I've already put it up on my S3 bucket. Alright, so we're going to go into the Hue environment. Once again, if you're in the EMR console, you just click on Hue and you'll get there. And I'm going to go to Query Editors, and I'll go to Pig. And I have a simple but functional environment here to write commands. So I can start typing commands in the center area. I have some help on the right hand side that will remind me of some of the functions I can tap into. We'll be using the count function in just a second. So a little reference to things that can be accessed. And I'm just going to pull the or copy the script that we're going to run from our GitHub site. So remember, the materials are at github.com/ryandata/bigdata. So if you go to that directory, you will see a file that says wordcount.pig. Click on that, and you can just copy and paste that few lines of text into the Pig editor. Okay, before I run this, I'll just step through what's going on. We're not going to get into details about syntax, but just to illustrate how this works and get a feel for it. We have the first line, we are loading the data, so we're loading it directly from the S3 location, the big data bucket 123s, where Shakespeare.txt resides. And let me say, so this should just run for you in your own environment without any special preparations. I will maintain access to the Shakespeare file in my big data bucket until a year after this workshop was created, so let's say June 2016. I don't really guarantee that it'll be up there after that, so if you are accessing this at a later date, you can put your own data up somewhere and run a word count on that. So then we have the second line where we are taking our loaded data and running through it and breaking it into words. That's what this function is doing. Then we group the words, and then in the fourth line we are counting the words with the count function. Then finally we store that output into a file that is on the cluster itself, in a directory on the cluster. So let's go ahead and run that. Notice that each line ends with a semicolon. That's just a syntactic feature. And let's run this and hope that this goes through. So now we see that actually it's a little different than running something on your local machine. We are reminded that it is a bit more complex job. We put the script into a queue, then it starts to run, then it starts to generate our relatively complex log output that reminds us that there's a lot of stuff going on here, of the job being split among multiple machines. And this is a small file, so it should run relatively quickly. And once it's done, we'll get a message that it's complete, and we can then start looking for the output. So we're now at 50%. I'll just let this run and not try to, and now at 100%. Seem to be doing pretty well. We're okay, and now we're green. Okay, so now the job is complete. This is a good result. So I can also go over to the job browser, and if I do that, I'm going to lose my program file because I haven't saved the script. I could save it, and then I'd have access to it later if I keep my cluster running. But I'm just going to leave that. I'm going to lose access to my script. We ran successfully, not a big deal. So now we can see I've actually been on this system a little bit, playing around with a few other things. So I have some other jobs that ran, but our latest one, the Pig Latin script, has succeeded. And it was actually launched by a thing called Oozie. You'll see Oozie pop up in different locations when you're browsing around here. Oozie is the task scheduler in the Hadoop environment. So Oozie received the request that we wanted to run a pig script, and it said, okay, let's get started with that, and started running it. From this screen we can also access the log files. So if something did not succeed, we'd get a message that said failed, and we could then go into the logs, look at the error logs, the standard error, and see what might have caused that. Now here we had a few things dumped to the error log which were apparently relatively minor. I mean, they're not things that stopped the job, so we were okay with that. And our syslog messages record all those sort of steps that we saw pop up on the screen. So the logs are maintained. We can figure out what happened. We can also look at metadata and see when things happened, how long a job took to run, how much memory and things was it using. And this, again, might help us in diagnostics of performance later on. So again, the interface makes it easy to access all that. But right now I want to go straight to the file itself. So I'm going to go to the file browser, and in this case I saved it under the Hue directory. So I go to user Hue pig word count. Okay, so it created this directory as part of my output, and I have a success message, and I also have the actual output. And I can pull that up and browse it on the screen. So you can see this is a long list, 150 page word list that I could also then download from the file browser and to my local machine if I wanted to. And if I go through this, I can first thing I notice is there's some some little fragments here that are getting counted. So some of these are probably page numbers, line numbers, strange bits of things. So the as is a word, as, so where there are 1,400 occurrences of as, that makes sense. But we also have, C colon is being counted. I would say this is not a very cleaned up file, not something you'd want to use for authoritative word count of Shakespeare. Kind of a rough and ready OCR perhaps of Shakespeare. But it does work, and if we scroll down we start to get to the longer words. We can see here's sapient, one occurrence, sapless twice, satisfy 21, saucily 2. So it's all there, and it completed this job. And we could throw that same algorithm against a much larger corpus that would be handled just as well on a Hadoop cluster. This would be a good time to point out that you don't run a Hadoop cluster for speed. You run it because you can't handle that volume of data any other way. There's a bit of overhead that just comes with splitting the job among multiple machines and putting it back together. So you're not gonna get faster performance than you would on a small job that could run on a single machine. But it's if your data can't be handled any other way. So the examples that I'm showing here are mostly relatively small, but they work the same way that they would if you were pointing them at true big data sources. Alright, so that is a word count of Shakespeare, and we've seen pig in action. We've seen let me just paste this in here one more time. A little pig program that gives you a flavor for how a pig program would work. And we've seen the pig editor that lets us manage these chunks of pig code and run and submit them to our cluster. So there's a lot of functionality here, and we could do all this on the command line as well. We can submit jobs on the command line in pig Latin, and you'd want to do that as you again built up a more production oriented system. But this is a great exploratory system. Alright, so let me take a moment to talk about S3. S3 is the storage environment for Amazon, and so I'm just clicking on that from the AWS homepage, and I have these things called buckets. So a bucket is simply a storage location. You could think of it as a directory name. They call it a bucket, and the one restriction of creating a bucket is the name has to be unique globally. Having just watched the Triple Crown winner American Pharaoh, it's same as a horse's name in horse racing. It has to be unique in the registry. No one else can have that. So you have to think of something that is not anywhere else. So if I do big data bucket 369, I can create that, That's not available. Somebody is using that. It might even have been me in the past creating a similar pattern. Let's do 370. That no one has taken before. I can create it, and I have my data bucket. This is now immediately accessible to me. I can use it in my account. I can point my scripts at it. I can store output in it, and I can also make it public by going under permissions and adding the permission, for example, to everyone, to let everyone list view permissions. You at least want to have them list and view the file if you do want to make it something that others can download. You could also create an open space where other people can put data. May be a little risky for your storage quotas and stuff. You will get billed for the amount of storage you're using. This is much cheaper to leave on for a long time than a cluster. You're talking, cents, unless you get into really big data amounts, really big data volumes. But for demo purposes, not that expensive. And once I've added these permissions, I can then say save, and now I have a new publicly accessible directory that I could have other people download data from. And again, for those of you who might be accessing this once Big Data Bucket 123 is not working anymore for whatever reason, just go into S3, create a bucket, and use that bucket location in your scripts. You'd have to modify the script to replace this location with your own, but otherwise everything should work fine. Okay, let me pause the video here, and we'll come back with Hive.